Yeah. Yes, yeah, good evening all. So myself, I'm Vijay. I hold a 20 plus years of experience in different technologies like big data, Hadoop, Spark, and working on different cloud technologies like Azure, GCP, right? Yes. So before I start, can anyone please confirm? Is my voice clear to all? Is my screen visible to all, right? Yes. Yeah, can anyone please confirm me, right?
Your voice is very low. Like we cannot very low.
Uh, is my voice low to everyone? Can anyone please confirm me?
Just say you are audible.
Okay. So as part of today's session, just I'll be discussing what is GCP, Google Cloud Platform, and data engineer. Data engineer with as compared with a traditional ETL developer, right? Traditional ETL developer, and who is a GCP data engineer? GCP data engineer, and what does a GCP data engineer do? GCP data engineer roles and responsibilities, and various GCP data engineering products and services, and job market of GCP, right? Yes. So starting from this cloud, yes. So here we'll be using Google Cloud, right? So various cloud service providers. What are the cloud, various cloud service providers, right? So not only this area like a GCP, we have got many other cloud providers, right? Yes. AWS, we have got Azure, GCP, Oracle Cloud, Salesforce, VMware, Liquid Web, and this Alibaba Cloud, right? Yes, we have got many cloud service providers. Among all these, right, most of the companies are preferring GCP, Azure, and AWS, right? Most of the companies preferring GCP, Azure, and AWS. Yes, so because GCP growth is increasing rapidly. So here GCP growth is increasing rapidly, right? Yes. So we store data, we read or retrieve data, we perform data analytics, we see high availability of data. Here data is safe and secure like Gmail, easy to scale, right? Yes. So GCP growth is increasing rapidly. It is one of the fastest growing network in this entire world, right? So today, like GCP has got a great demand. This Google Cloud Platform, as when if we are comparing with Azure and AWS, right? So I was talking. These are the various cloud service providers. Various service cloud providers. Not only we have got many cloud providers, and that the mostly used ones are AWS, Azure, and GCP, right? Yes. We talk about this data engineering, right? As compared with the ETL developer, traditional ETL developer just is going to extract data, is going to transform and loading. But a typical data engineer should have the knowledge about various things. So you need to play with the data. You need to handle the data. Data engineer, you need to handle the data. You need to work with all varieties of data, all formats of data. You need to work with structured data. You need to work with unstructured data, semi-structured data. You need to work with streaming data. You need to work with NoSQL data, all varieties of data, all formats of data you need to work with, right? As compared with this ETL developer. So traditional ETL developer, previously, if you go back like 10 to 15 years back, there is no ETL developer, right? So currently we see data engineer currently. So today we see like data engineer, he need to play with the data. He need to handle all varieties of data. He need to pull the data. He need to extract the data from various sources. He need to extract it. He need to transform. He need to process. He need to perform various operations, grouping data, filtering data, merging data, sorting data, different operations, transforming. He need to perform all this. He need to perform ETL things. He need to monitor the data. He need to secure the data. He need to make that the data is secure at each step of the process, right? And making that the data is secure at each step of the process without any data leaks or data exposures, right? Yes. So just coming back, right? Yes. Companies are migrating towards GCP. Just here, companies are migrating towards GCP. Companies are migrating towards GCP. So here, understand here, Google uses for example, today, like you are watching some YouTube videos, means you are storing the YouTube videos are getting stored, Gmail messages are getting stored, Google search engines data is getting stored. So Google is using the same infrastructure. Google is using the same infrastructures for the using for the same way GCP using the same infrastructure for storing and computation data. It is using the same infrastructure for storing and computation data. Here we are storing data. We can read or retrieve data. In GCP, Google Cloud Platform, we store, we read and retrieve data. We perform data analytics. We see high analytics, high availability of data. The data is safe and secure like Gmail and easy to scale. And it is easy to scale. GCP is flexible and it can fit at any level of organization. It can fit at any level of organization, big or small or large data or small data, right? Yes. Yes. AWS, Azure, GCP. So which one is why to choose GCP? Why we need to go for GCP? Okay, there are many reasons. I'll say many reasons why we need to choose for GCP. One by one, you can just check it here. Fast biggest network in the world, right? It is one of the fast biggest network in the world. GCP, right? Yes. Google has got data centers throughout the world. Google has got data centers throughout the world. They used high-end virtual machines. They use high-end virtual machines, right? And even petabyte bandwidth, high performance, and separation of compute and storage. Separation of compute and storage, right? Each individual virtual machine will have its own separate RAM and also its own separate data storage. They are going to have each separate data storage. Each cluster will have a number of nodes. So even not only this pricing, flexible pricing. GCP has got flexible pricing as compared with other like AWS and Azure. Discounted price for long-term running workloads, right? That is if you want for going for 5 years, 10 years, right? In few cases, only GCP services, only in few cases the GCP services are high, but overall GCP's profits, GCP prices are flexible. GCP prices are flexible. Yes. And also like customization, right? Yes. Wide range of customization for any instances. See here, customization means a wide range of customization for any instance. Once again, can anyone please confirm whether my voice is clear and loud?
Yes, sir, you're audible.
Okay. So in cloud, we create many instances. We create many instances, right? For that instance, we can customize depending upon your requirement. If we can have 1 PB of storage or different softwares we need to install. So we can do all this kind of customizations. And even scalability. Scalability means increasing or decreasing, capacity increasing or capacity decreasing. For example, you have taken for 1 year and it got filled. You need to increase the scale. In Azure or AWS, they are not that much flexible, but here in GCP, it is flexible, right? We can increase or decrease. Live migration. What is that? Live migration, right? Yes. Supports live migrations of virtual machines in GCP, but Azure and AWS doesn't support this kind of live migration. Means whatever existing systems, for example, your data is stored in Hadoop, you can lively migrate into GCP without impacting existing data. If we talk about big data or ML, we get inbuilt and pre-trained machine learning and AI APIs in GCP. Free trials. Some services free for 3 months. Some services are free for 12 months. Some services are lifetime free. And customer systems migration, existing data migrations, for example, like Twitter, Vodafone, HSBC, New York Times, Coca-Cola, and many others like Spotify, all these things, right? Existing data migrations, right? Yes. So data engineer versus this ETL developer. Yeah. Everything deals with the data. Here, everything deals, data engineer means everything deals with the data. So data, today's world flooded with the data. Today's world flooded with data. Data has got experience. Data has got future reference. Using data or these things, we perform many activities, right? We perform many kinds of activities. In that, data has got experience and future reference. Data engineer deals with the data, that is data management, data storage and data processing. Data storage and data processing, right? Yes. Data engineer should, just now I was saying that data engineer should handle all varieties of data. You need to work with structured, semi-structured, unstructured, should work with streaming, should work with NoSQL data, should work with all formats of data. Data engineering involves, so this data engineering involves, right, handling the data, ingesting data, extracting data, storing the data, filtering the data, transforming data, processing data, merging data, sorting data, grouping data, analyzing data, right? Yeah. It also involves how to extract data, that is the sources, what are the sources of the data, what are the sources of the data, what is the format of data, how to process the data, and what is the destination of the data, how to extract the data, what is the format of the data, how to process data, and what is the destination of the data. Different sources, right? IoT apps from different sources, like IoT applications, from where you are going to extract the data. You load it and you store it, and later you process it, and just you are loading into the target things, right? A data engineer designs and maintains an entire organization's data infrastructure. Data engineer maintains the entire organization's infrastructure. So it includes like complex data pipelines, big data technologies. You need to, while ETL developer just focus on ETL process, data engineer has got a broader and more architectural role, right, as compared with this ETL developer. Yes, we see data engineer is going to design, build, and maintain the overall data infrastructure, data pipelines, and databases. He handles with big data technologies, cloud services, means you need to have knowledge on these big data technologies, cloud services, cloud data, and also like data preparation for ML, machine learning, implementing both the batch and real-time solutions. Yes. If we come to this again, a GCP data engineer, what a GCP data engineer does? Ensures data quality, data storage and processing, collaborating with the data scientist and analyst, monitoring data infrastructure, data security, data monitoring, right? All these things. Data engineering, GCP data engineering, right? It's a process of transforming raw data. A data engineer, what he does is it's a process of transforming raw data into useful format, usable format, which is later analyzed by other teams, cleansing, organization, and manipulating data. Cleansing, organization, and manipulating data using pipelines are some of the key responsibilities, of a data engineer. So we work on applying data engineering principles on Google Cloud Platform. So a GCP data engineer, right? You need to collaborate with engineers, marketing teams, product managers, sales associates, so that for identifying the customer behavior, right? All this. And the key GCP products, the key GCP products are services. Cloud storage, in a simple way, in a simple word, I'll say, for storing data, cloud storage for storing data, BigQuery for fast querying, storage and analysis of large data sets, Dataproc for big data processing and analytics, Dataproc for big data processing and analytics, Databricks for PySpark processing in GCP. We have got data flow for stream and batch data and for batch data processing. Cloud Composer, right? We have got a Cloud Composer, Apache Airflow for automating and monitoring data pipelines. For automating and monitoring data pipelines. Pub or sub for messaging and for data ingestions. For messaging and for data ingestions, right? Yes. So GCP products, they are categorized into 4. Understand carefully, GCP products are categorized into 4. App engine, compute engine, container. So first thing, categorized into 4. One is compute, one is storage, big data, and machine learning. So mainly they are categorized into 4. Compute, storage, big data, machine learning. Again, in compute, we see like app engine. Just understand here. App engine, compute engine, container engine, cloud run, even we see like cloud functions. App engine, a platform. You can see app engine, nothing but a platform for building web applications and mobile applications. Compute engine, large scale workloads. So here if we say compute engine, right? If we talk about compute engine, large scale workloads. For large scale workloads, right? You can go for it. Container engine for running Docker containers. For running, right? Docker containers on Google's infrastructure. Cloud run, fully managed compute platform for deploying, scaling containerized applications very quickly and very securely, right? Yes. Now, if you talk about the storages, right? Mainly there are 4 kind of storages: object, relational, non-relational, data warehouse. Object, relational, non-relational, NoSQL, and data warehouse. Understand? Object like a cloud storage, object like cloud storage, right? Yes. Good for object data, images, media, backups for these things, right? A relational database, relational like Cloud SQL and Cloud Spanner. Cloud SQL, good for web frameworks and for e-commerce kind of things. Cloud Spanner is good for this RDBMS. Non-relational or NoSQL, you can see in GCP, non-relational NoSQL, we got Cloud File Store and Bigtable. Cloud File Store, it's good for high and mobile applications and web applications. And Bigtable, good for heavy reads and writes. Bigtable is for heavy reading and writing operations. And data warehouse, like we have got a BigQuery. enterprise data warehouse, just for analytics and for dashboards for these things, right? We have got a BigQuery. And also we have got a big data like a data proc, data flow, Databricks, PubBar Sub, and BigQuery. Just now I was briefing you about these products, right? Yes. And also ML, machine learning, vision API, speech API, translate API, speech API, machine learning for all these things, right? Yes. Mm. So if I talk like in this big data has bought, so big data computation like a big data, Hadoop and Spark. If you talk Hadoop, it has brought a revolution, in this distributed computing, right? Yes. So like we see like a Spark, Hadoop and Spark processing, very high speed processing. If we talk about Spark, very high speed processing, like huge data, like terabytes or petabytes of data processing at very quick time, right? Yes. It uses distributed computing and parallel processing, right? Yes. But I like we'll be using like technology like Spark, like PySpark we'll be using. So if you see this, I said these things are for PySpark processing. For PySpark processing, we have got Databricks, Dataproc, right? It's a PySpark is one of the lightning fast technology that is designed for fast computation. Say PySpark like Spark with Python implementation. Say one of these, it's a Python API to use a Spark. It is one of the demanding tools among the data engineers to work with the bigger data sets. So this PySpark we can run like a distributed SQL, and as I said, distributed computing, and creating data pipelines, ingesting data into databases, running some kind of machine learning algorithms, one running with also we can work with graph algorithms, working with the data streams, streaming data which keeps on incrementing, data which keeps on generating such data, right? Yes. We work with many packages, mainly like PySpark features, massive MPP, massive parallel processing. So in-memory computation, right? In-memory computation, storage and processing both happening in the memory level, right? Yes. Like parallel processing, lazy evaluated. Lazy evaluated means like on-demand execution, right? And see like Databricks providing cluster for it. So Spark to run, right, we require a cluster. So who provides the cluster? Databricks provides a cluster. So in this way, we will be working with this PySpark processing. And also like I'll be discussing about a Terraform, the infrastructure as code that lets you define some both cloud and on-premise resources, right? Yes. So these are the things I'll be discussing, right? Yes. So here you can see categorized into four like compute, storage, big data, and machine learning, right? Yes. The case of compute, four. In the case of storage, object relational, non-relational, and data warehouse. So again, in relational, we see Cloud SQL, Cloud Spanner, non-relational or NoSQL like Bigtable or Cloud Firestore. Data warehouse like we see like BigQuery. And I said like big data, like data proc, data flow, data bricks, PubBar, Sub, BigQuery, and machine learning, right? So as part of this, I'll be discussing, you see in brief, in depth, I'll be discussing about the things. If you see the course content, what I'm going to discuss for this, and check with this 1 second. Just hold on. So this is what I'll be discussing. If you just check it, what are the module 1 GCP data engineering fundamentals, like Google Cloud Storage, like GCS, right? And Cloud SQL setting up databases, module 3, BigQuery for building a data warehouse. In brief, I'll be discussing about these things. Data proc, big data processing, data bricks for PySpark processing, and data flow, Apache Beam development, Google Cloud Composer like orchestration, data fusion like data integration service, and DBT, data build tool, Airflow, and Terraform. So, starting with, if we can check with this course content, right? So introduction to this Google Cloud Platform, overview about this cloud, IAM, identity and access management, everything I'll be discussing from the scratch ground level, right? See how to get the free subscription onwards, like billing and cost management, GCP data engineering fundamentals, what do you mean by batch processing and real-time processing, data engineering roles and responsibilities, setting up with starting with GCP, signing with GCP with a Gmail account or with a dummy account, whereby providing your dummy details, fake details, overview of GCP credits, GCP project. Why GCP project? Without project, you cannot perform anything. GCP billing and Cloud Shell. What are the different ways where we can interact with GCP services? Like we have console, we have got the Cloud Shell, we have got like the Cloud SDK. One by one, I'll be briefing. We have got various methods to interact with GCP services. And we have got storages and databases in GCP like Cloud Storage, BigQuery, Cloud SQL, Cloud Spanner, Firestore, Bigtable. First, in brief, I'll be discussing about one by one. So in this Google Cloud Storage, GCS, in that setting, how to set up data lake using GCS. You can see this everything. You can just go ahead like overview of data sets. Just a second. Google Cloud Storage, setting up a data lake using a GCS, right? Managing buckets. Okay, overview of setting up data lakes using GCS. We can just check with this as in brief, in depth we'll be discussing. Cloud SQL, set up a Postgres database using Cloud SQL. Overview of, okay. And also like MySQL, data ingestion and data integration like PubSub, data flow, data processing and transformations, data warehousing, BigQuery for building a data warehouse. In brief, in depth, we'll be discussing about it. And the data proc like big data processing and ELT data pipelines using data proc. And just to go ahead with this data bricks, PySpark processing in GCP, and also like ELT pipelines using the Databricks, integration of Spark and Dataproc and BigQuery, data flow, Apache Beam development, real-time analytics, integration with other GCP services, PubBar Sub, Google Cloud Composer for data pipeline and orchestration, data fusion, data cloud functions, Terraform, data pipelines using data build tool, Airflow and BigQuery. Yes. Machine learning in GCP, security monitoring and real world GCP data engineering scenarios, right? So these things like 25 topics in brief, in depth we'll be discussing. All right. You can just check with this. So offerings from my side, live is you will be getting each and every session video, soft copy of this class notes. You'll be getting the soft copy of class notes, assignments and tasks to work with, a WhatsApp group for technical discussions. Even if you got any errors, you can take snap of it and post in the group. Interview questions, around 200 questions, interview questions will be discussed. Live interactive hands-on sessions, wherever required, you can do the things parallelly along with me, the installations, the other things, right? Apart from this, these things, right? What are the offerings from my side? And so there are some offerings from DurgaSoft, right? Like you will be getting Unix, Linux, shell scripting videos, around 120 videos you'll be getting, right? Around 120 videos of Unix, Linux, shell scripting. It's a free access will be provided once you get enrolled for this course. MySQL videos 35 and basic Python videos you'll be getting, right? Not basic Python videos, you'll be getting total Python videos. You'll be getting Python videos, right? People who doesn't have knowledge in Python, you can just check with. Even as part of the course, I'll be just briefing you about the Python syntaxes which required for this course. And I said I'll be discussing about like Terraforms, where we can reuse a consistent workflow provisions. Cloud Run, I'll be discussing fully managed platform to run your code directly on the Google scalable infrastructure, cloud functions. Okay. So if you've got any queries, so from tomorrow we'll be starting with the actual things. From tomorrow, we'll be starting with the actual things. So that let me make it clear about the timings of this batch. Initially, the demos will be at 6 p.m. It will be the demos will be at 6 p.m. But actually, the timings of this batch. Let me make it clear about the timings of this batch. It will be from 4 p.m. to 6 p.m. Right? The timing of this batch will be from 4 p.m. to 6 p.m. Let me once again repeat. Yes, this is before you go with the payment process. So everything in brief we'll be discussing. So we'll be we'll building many data pipelines to get data from multiple sources, creating data warehouse, then from the data lakes or data warehouse to downstream the systems. Okay, we build data engineering pipelines using GCP, right? So, and if you talk about job market GCP, right? Becoming a cloud data engineer, now it is the correct time, and the cloud computing and data engineering skills are increasing in demand as companies are digitizing themselves, their solutions to transform, right? Yes. And here I said, according to the pay scales also, data engineers has got the highest average salaries as closely as data scientist. The two highest paying jobs like data scientist and data engineers, right? So here pursuing a data engineer will never let you down. So today, even if you see in 2024-25, so like AI and this cloud technologies and this data engineering and data science AI and this cloud technologies has got a great demand, and you would see a lot of jobs. You can check with that. Even GCP, I said, one of the fastest growing network, right? Yes. And even if you see uh, companies like Facebook, Intel, Microsoft, Amazon, all these are interested in hiring data engineers at a great salary packages. Even you see like companies like Google, Apple, Walmart, Cognizant, they're offering high paying jobs for this data engineers, right? So you can see like a great demand for this GCP data engineering. And that too GCP, I was showing you, I was just briefing you about one by one why you need to choose for GCP as compared with Azure and AWS, right? Even I take batches on Azure data engineering and GCP data engineering, but today if you see like GCP is mostly preferred. Okay, I showed you that one by one why GCP is preferred, right? So if you got any queries now, you can go with your queries, right? Yes, that is what as part of the course content. From tomorrow, we'll start with the actual things. So I'll start with subscriptions, how to get a free subscription for GCP. So one thing is either identity verification through credit card will be done. Either you can say UPI payment or credit card payment or net banking payment. Just 2 rupees will be credited from your account just for identity verification. Again, they will be credited back, right? Yes. One Gmail ID or with the dummy Gmail ID also we can create this. Yeah, for all this you can perform, right? Okay. Okay, if you got any queries, you can go. From tomorrow, we'll be starting with the practical things. From tomorrow, just I'll be showing you things, right? Yes. So just get enrolled for getting all these videos and also the prerequisites like Unix, Linux commands, MySQL, and this Python. You can just go through. Meanwhile, it's a weekend batch. Weekend like 2 hours on Saturdays, 2 hours on Sundays, right? 2 hours on Saturdays and 2 hours on Sundays. You'll be having the sessions. It goes for around 12 weekends, around 3 months. It goes. Wherever required, I'll be taking some bigger sessions like 2.5, 3 hour sessions. Yes. Any queries from your side, anyone? Just check with your queries. Okay, fine. So if I'm done with the queries, if there are no other queries, so tomorrow also people can attend the session, same timing at 6 p.m. using the same link. To see more discussion from tomorrow, we'll go with the technical things, will practical things, right? Yes. So fine. Thank you all for your time. Thank you. Meet you tomorrow at 6 p.m. using the same link. Yes. Bye. Good night.